All right, so today we're going to talk about motion, acceleration, and forces. This unit today, we'll talk pretty much exclusively just about motion. Okay, talk about just about motion. Talk about acceleration tomorrow. Make sure you watch your video tomorrow, and then also talk about forces on Monday. Okay, so y'all make sure you watch your video. This is last day of next Tuesday. So motion, acceleration, and forces. This is really a preview unit. Okay, really motion and acceleration and these type of forces aren't necessarily something that are explicitly needed. Okay. However, these are the basis for what we're going to talk about a lot. We talk about Newton's laws of motion and even go further on and stuff like that. Okay, so this is the basis. This should be pretty much review. Okay, this should be pretty much review from what you've done in the past. This should be relatively easy. Kind of a quick refresher unit here. Let me find my mouse. All right. So motion is defined as a change in position. Ooh, man, look at that great animation. Motion is a change in position, okay? So a couple of questions about this right now. Are you in motion? You say yes. Why? Because we're always moving, okay? Because we're always moving. You said no. Why? You speak loud so they can hear you. Are you moving right now? Are you? No. Why? Is the earth moving right now, though? So are we in motion? In fact, we are not in motion, okay? Because we talk about motion, we talk about relative motion, okay? You're sitting in your chair, okay? Would you say on earth you're moving? Because all three of you are moving at the same thing. You're always this far apart away from each other right now, aren't you? Which is about 15 feet away from each other. You kind of form almost an equilateral triangle. So motion is what we're going to talk about. The earth is in motion, okay? But we necessarily say right now you are not in motion because you are not moving, okay? So we talk about relative motion. But, you know, in the broad universal sense, yes, you are moving because the earth is moving in two different ways. The earth is spinning and it is rotating around the sun, okay? So when we talk about relative motion. Or most of the time would you say you're not moving right now because we're moving relative to the earth, okay? We care about distance and time when we're talking about motion, okay? We're talking about distance and time. So motion is defined as a change in position. So how are we going to describe that position, that change in position, either through distance or through distance and time, okay? Distance and time. How far did you move? How long did it take you to move, okay? Can someone tell me in one way where motion is described as distance and time? In everyday way, how motion is described in distance and time. What? How is motion described? How is a change in position described as a distance and a time? Every one of you have seen it today and been affected by it today. The speed limit, correct? Miles is a distance, correct? And time and hours would be a time, correct? So by going the speed limit, I mean, Gracie, you didn't drive, well, the yellow dog, you drive the yellow dog, your mom bring you to school. Becca brought you to school. She didn't drive 120 mile an hour on Highway 62, did she? No. Okay, she followed the speed limit. Okay, she followed this. Well, I hope she somewhat followed the speed limit. But so that's it. So that is how we describe distance, motion as distance and time. Now, do we know all motion occurs necessarily? Even though we don't see it. The example I have on there, is everyone going to get mail today? Who's going to see the mail truck? I mean, of you guys, are you going to see the mail truck? But you know what happens, okay? But you know what happens, okay? Just like, you know, did you see everyone get to school today? But did everyone that came to school have to get to school? No one's living here, okay? So that's where we don't actually see it happening, but we know that it has to. So motion is a change in position. Distance versus displacement, okay? Distance is how far you moved. How far you moved. So, how far do you live from school? Who knows? What? Who knows how far you live from school? Nobody? So if you figure out the speed, you can figure that out. No one knows how. That's pitiful, people. I live 2.8 miles from school. Okay, that's the distance I go from school. Okay, how far an object moves. Okay, we know Sikeston is what's the distance from here to Sikeston? People. I'm not picking on the Wyatt girl back there. I mean, it's a little bit different. How many miles is it to Sikeston? Pretty close for you. 15 from Charleston. Okay. Then why didn't you say anything? That's what you get for being a Kentucky fan. But distance is how far it moves. Displacement is how far and in what direction. So let's say that Owen lives he probably doesn't live that. Let's just say he lives 0.8 of a mile from school, okay? And he goes from home to school and then from school to home. What's his distance? How far did he move? 0.8 of a mile to school plus 0.8 of a mile back from school, correct? So it's 0.8 plus 0.8. 1 so his distance is 1.6. 8 plus 8. Keep the decimal. Is 8.6. Now, what's his displacement? What's his displacement? His displacement is how far and what direction it moved from its start position. So what is Owen's displacement, and probably everybody's displacement almost every single day? Where did you start? Where did you start your day, Owen Hassan Willis? At his house, okay? Where are you going to end your day? Where are you going to end your day today? Where are you going to end your day? You're going to end your day at school. You're going to sleep You started your day at home. Where are you going to end your day? At home. So what's his displacement? He's in the exact same spot, isn't he? So his displacement would be 0, okay? His displacement would be 0. His distance would be more than 0, wouldn't it? So here's another example of this. Let's say Will Darius finally gets him a hit, okay? Will Darius hits a home run. Will Darius, how far will you run? How far are the bases apart? 90 feet. So if you hit a home run, how far are you running? No. How far what's your distance? How far do you run? There's 4 bases, isn't there? So 90 times 4 would be what? 90 times 4 would be what? 360. Your distance would be 360 feet. However, what would your displacement be? 0, because you ended up at home plate. You started home plate, you ended up at home plate, right? So there we go. All right, so now we're going to do an example of this. I need a volunteer. Okay, stand up. Come stand over here. I want you to take 7 steps forward and then 3 steps backwards. That way, face going that way. Okay, what was his distance? How many steps did he take? How many steps? If you took 7 forward and 2 backwards, how many steps did he take? You took 3 backwards? I'm sorry, 10, yes. 7 steps forward and then 3 backwards, 10. That was his distance. What was his displacement? 4. Positive 4, correct? Because he ended up 4 steps in front of where he went. Take it back to your starting position. Back to your starting position. I know you're used to sitting down in the starting position. Riding the pine pony. Okay, I want you to take 4 steps forward and then 10 steps backwards. What was his distance? 14. What was his displacement? Close. 6 is the right number. -6. Because forward is positive, correct? Negative be backwards. So his displacement would have been -6. Okay, back to your starting. Whoop. I want you to walk. I want you to walk around those 4 tables and then the back. Let me do the mental before. So, I want you to count your steps as you go. 1, aloud. 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, 13, 14, 15, 16, 17, 18, 19, 20, 21, 22, 23, 24, 25, 26. So, Owen walked around a set of desks, okay? Walked around a set of desks. What was his distance? 26, I think is where we ended at. 26, okay? What was his displacement again? 0, because he ended up in the exact same spot, okay? You see the difference between distance and displacement right now? Your distance, let me back that up. Your displacement will never, ever, 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 ever be greater than your displacement, or than your distance, okay? Your displacement will never be greater than your distance. It could be the same, okay? It could be the same, but it will never be greater. I like to think of it this way, and the last way to really differentiate distance and displacement. Gracie, if you've ever heard the term saying, as the crow flies, do you drive the fastest way to school? You always learn that the shortest, you can sit down now, the shortest distance between 2 points is a straight line. You live pretty much right there, don't you? Just directly east of us is where you live right now. Due east. But do you only drive east? You have to follow the roads, correct? Okay. Her displacement in this case was almost due east, but her distance, when she leaves school, she has to drive north. And then she drives east. And then she drives south. And then she drives east. And then she drives south again to get to her house. Yes. So that's how she gets there, okay? That's how she gets there. Anybody ever use the Find My Friends on the iPhone? I can tell you right now, let me find my phone. I can tell you right now that my dad, or we'll go with this. Let me pull somebody up. Let's see who pulls up first. So I Find My Friends. I can see Find My Friends. Right there it is. My dad is 0.3 of a mile away from me. Okay? From the first screen, it tells me he's 0.3 of a mile away. That's as the crow flies. He is exactly 0.3 of a mile. But then if I click on him, it tells me he's 0.5 of a mile away. Okay? Because he can't just drive through people's yards, can he? He has to follow the road. He was 0.3 of a mile straight through people's yards. He didn't have to go just boom that way. He didn't have to go through the parking lot onto Thorn Street and stuff like that. Okay, so that's distance and displacement. Another example I can make of this is when I lived in town, I used to ride my bike. I lived exactly 1 mile away from school, from my other house. Exactly. From the front door of my house to this door right here. I could ride my bike faster to school than I could drive it, or as fast as I could drive. So I could ride my bike directly up to the school. I could cut through a parking lot. I could cut through someone's yard, okay? When I drove, I had to follow the road, okay? So that's distance and displacement. Distance is how far you go. Displacement is how far you actually move. All right, speed. Speed is the distance an object travels per unit time, okay? Speed is distance divided by time. The SI unit of speed is meters per second because the SI unit of distance is meters. The SI unit of time is seconds. Now, we can also, I had the other thing on there, velocity is displacement divided by time, okay? You can have a negative velocity if you drive backwards. You can't have a negative speed, which I think I get that here in a little bit, okay? Calculating speed. Calculating speed that you are running if you run 400 meters in 72 seconds, okay? So I'm gonna work this on something different. Make sure that's the right screen that's shared. So in this, I traveled 400 meters in 72 seconds. I can draw what's called the speed triangle, okay? The speed triangle, it's a triangle. S stands for speed. D stands for distance. T stands for time. So if I'm looking for speed, I cover up the S, and what does S equal? Distance over time, okay? If I'm looking for time, I cover up the T. What does time equal? What's on top? Distance over speed, okay? Distance over speed. If I'm looking for distance, how do I calculate that? They're next to each other, so what do you do? Multiply. So distance is speed times time, okay? ST, okay? Distance, speed times time. So back to this question, it tells me that my distance was 400 meters. I'm sorry, I write like a 3-year-old. And time, it's a lot harder than it looks, is 72 seconds. I'm looking for my speed, and I want you to show your work when you have things like this, okay? So you have to take a picture. Actually, I lied to you all ago. Tomorrow we'll be doing calculating speed, so I'll do some more examples, and then you'll have to. So it won't be actually a PowerPoint. Monday we'll do acceleration. So I'm looking for speed. So what does speed equal? I cover up S. So what does S equal? So S equals distance over time. So that equals 400. That was a question mark right there. Equals 400 over 72. Someone with your Chromebook out? Is your internet working? Oh, I just did it on my phone. So I would do 400 divided by 72. And my speed would have been 5. It got 5.555556. I only ever need 3 numbers, okay? So speed equals 5.56. What are my units? Where's my units of distance was meters. My units of time was seconds, okay? Pretty simple stuff. You've done that all before, haven't you? All right, next thing. Let me make sure I got my correct slide up. Oh, wrong thing. Not bad. All right. Share. Make sure it's still on that. Share. All right, so calculate speed. So I did that, okay? So types of speed. There are a lot of different types of speed. There are really 4 different types of speed. Constant speed is speed that doesn't change. You set your car on cruise control, okay? And you go the same speed all the time. Changing speed is kind of common sense. It's the speed changes. You know, this example of this is you ride your bike for 5 kilometers. Before you start, what's your speed? Before you start pedaling your bike, what's your speed? 0, okay? You pedal your bike, your speed increases, doesn't it? And then you decide you probably need to slow down, so your speed decreases. And then you stop or speed up again, okay? That's changing speed. Average speed is total distance divided by total time, okay? Your average speed is total distance divided by total time. How far you went, how long it took, okay? So if you know that you had, like I went to South Dakota this summer, okay? It was 2,000 miles away where I went. It took me 21 hours. If I wanted to find my average speed, I would have done 2,000 divided by 21, okay? That taking into account to me stopping and getting diesel, me stopping letting my horses out, me stopping eating lunch, okay? Stuff like that. Me stopping for the blowout on my tire. That was my average speed. We mostly referred most of the time in our speed to our instantaneous speed. It's a speed at any given moment. What shows your instantaneous speed? What shows your instantaneous speed? It was a vocabulary term. What shows your instantaneous speed? Nope. How does that show your instantaneous speed? Everybody's seen it. Walking wasn't a vocabulary term. Your speedometer, correct? In the car, that shows your instantaneous speed. That's where the speed look. Everyone know what I'm talking about? I kind of have that look, but like, what in the world are you talking about? Look, your speedometer shows that. Okay, your speedometer shows that. So your speed limit is telling you that the instantaneous speed has to be 55 miles per hour, 70 miles per hour. So if you want to be a smart aleck one time when you turn 16 to a cop or something, and the cop pulls you over and tells you know how fast you were going, you could say, well, yes, sir. I've left my house. I've gone 10 miles. Or I've gone 50 miles. And it's taken me 1 hour. So my speed was 50 miles per hour. And you'll say, no, you were going 94. Well, that was my instantaneous speed. You didn't ask what type of speed I was talking about, okay? Your speedometer shows your instantaneous speed. Your speedometer shows your instantaneous speed. All right. Graphing motion, okay? This is what's called a distance time graph, okay? So we can describe what happens in this graph, okay? So at 0 minutes, he stopped, isn't he? What's happening from 0 minutes to 10 minutes? He's moving, correct? He's moving. What about from 10 to 20? Is he moving, or is he speeding up, slowing down, or stopped? He stopped, okay? Because his distance isn't changing, is it? His distance isn't changing. From 20 to 30, what's happening? What? He's speeding up, okay? And he's going at a constant speed, isn't he? He's going at a constant speed because that's a straight line, correct? If he was going at a non-constant speed, it would be a crooked line, okay? And then what about from 30 to, 40? He has stopped again, isn't he? That's a distance time graph. He stopped. He speeds up. He stops. He speeds up. He stops. That's graphing motion. That's a distance time graph. You'll have to answer questions about that. Oh, there's a distance time graph. All right, velocity. Velocity includes speed and direction, okay? So the storm is moving at 20 kilometers per hour. Should you be seeking shelter? Is that a velocity or is that a speed? It's a speed because it has no direction, correct? If it was telling me it was moving 20 kilometers per hour east, that would be a velocity, okay, because it gives me the direction. Okay, two trains are going, this is a really good question. I want you to know the answer why. Two trains are going the exact same speed. And remember, speed is velocity is almost the same thing. Speed is distance divided by time. Velocity is displacement divided by time. So two trains are going the same speed but have different velocities. Why? They're going two different directions. Very good. Okay. They are going two different directions. Same thing. The race car is going around an oval track. He's got his cruise control on. He's going 200 miles per hour. Why is his velocity changing? Okay, he's turning, so his direction's changing, okay? So does everyone understand the difference between speed and velocity right now? I've seen one affirmation. Other two people are just sitting there. You understand the difference between speed and velocity? There's two affirmations. There's three affirmations. Thank you. Oh, well that's it. Okay. So you got some homework today, and if you have any questions, please let me know.